Welcome to Across the Globe. Today we will learn about logical operations in R. Logical operations in R are essential for comparing values and generating logical outcomes. Using logical operators such as equals, equis, det eats, equals, and, users can evaluate expressions to obtain true or false results. For example, in a data set, one could use the logical operator to compare the values of two columns and identify instances where one value is greater than the other. This can be valuable for filtering or conditional operations in data analysis or coding tasks. In programming, logical operators are used to compare values. The GANT operator checks if the left operand is greater than the right operand. For example, 5-3 evaluates to true. The Kiplitz operator checks if two operands are equal. For instance, 4 equals 4 results in true. Lastly, the equals operator checks if the two operands are not equal. So, 2 equals 2 yields false. These operations are commonly used in conditional statements to control program flow based on the comparison results. When working in R, you can use the and, or operators to combine multiple logical operations. The AND operator is used to require that multiple conditions are met, while the operator is used to select rows that meet at least one of the conditions. For example, if you want to filter a dataset for rows where two conditions are true simultaneously, you would use the AND operator. Conversely, if you want to filter for rows where either of two conditions is true, you would use the operator. Logical operators can be combined using the AND operator in R to create more complex conditions. For example, to check if a number is greater than one value and less than another, you can use the greater than and then less than symbols in conjunction with n. Consider the expression 5, 3, and 5 and 7, which evaluates to true because 5 is indeed greater than 3 and less than 7. Similarly, the n operator can be used to check if a value satisfies multiple conditions simultaneously. In the statement 4 equal to 4 equal 5, the equal operator determines if 4 is equal to 4, which is true, and the equals operator checks if 4 is not equal to 5, which is also true. Therefore, the overall outcome is true because both conditions are satisfied concurrently. In R, the OR operator is used to combine logical operations. It evaluates to true if at least one of the conditions is true. For example, in the first snippet, 5 and 7, 5, 10 evaluates to true because at least one of the conditions, 5, 10, is true. In the second snippet, 4 equals 3, 4 equals 4 also evaluates to true because one of the conditions, 4 equals 4, is true. Therefore, the tring operator combines logical operations by checking if at least one condition is true to give a final true output. Using logical operations in R is like following a recipe to bake a cake. Just as you follow steps in a recipe to achieve a delicious cake, you use logical operations in R to achieve a desired outcome. Each step in a recipe corresponds to a logical operation in R code. For example, just as you add flour and sugar together in a recipe, you can use the AND operator in R to combine two conditions. By following the recipe, utilizing logical operations, you can successfully bake a cake, achieve your desired outcome in R. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code snippet above serves as a metaphorical representation of baking a cake to illustrate the utilization of logical operations in R programming. Each step in the process of baking a cake corresponds to a logical operation utilizing the logical AND operator and end in R. 1. Gather ingredients. In this step, various ingredients such as flour, sugar, butter, and eggs are assigned specific quantities. 2. Preheat oven. The desired temperature for preheating the oven is set at 350 degrees. 3. Mix dry ingredients. The condition dry ingredients ready checks if there is sufficient flour and sugar available. 4. Cream butter and sugar. The condition butter sugar ready verifies the availability of both butter and sugar. 5. Beat in eggs. The condition eggs ready ensures there are enough eggs for the recipe. 6. Combine wet and dry ingredients. The ingredients combined condition confirms that all required ingredients are available to proceed. 7. Pour batter into pan. The batter ready condition signifies the readiness of the batter for baking. 8. Bake in oven. The cake baked condition guarantees that all prerequisites are met, including the oven being at the right temperature to proceed with baking. 9. Cool and enjoy. Based on the final condition cake baked, a message is printed either celebrating the successful baking of a cake or acknowledging an obstacle in the process. By correlating logical operations in R to a familiar activity like baking, this code example simplifies the understanding of logical operations and their role in achieving desired outcomes or troubleshooting unexpected results, making programming concepts more relatable and easier to grasp. In a manufacturing setting, logical operations in R can be applied to quality control processes. For example, in an automobile production plant, logical operations can be used to ensure that all components of a vehicle are assembled correctly before it moves to the next stage. By defining logical checks at each assembly point, such as verifying that the engine is installed, and the wheels are attached, the production line can be halted if any of these conditions are not met, preventing the manufacturing of defective vehicles. Likewise, in the context of supply chain management, logical operations in R can be utilized to optimize inventory levels. By setting logical conditions based on factors like demand forecasts, production lead times, and safety stock levels, companies can determine the optimal quantity to order for each product to minimize holding costs while ensuring sufficient stock availability. This enables businesses to efficiently manage their inventory levels and meet customer demand effectively. In conclusion, logical operations in R play a crucial role in various industrial applications, from ensuring quality control in manufacturing processes to optimizing inventory management in supply chains, ultimately contributing to increased efficiency and productivity across different sectors. Keep learning, stay curious, and I'll catch you in the next video.